All right, our next example, we're going to analyze a linear function. Tamika records the outside temperature at 6 a.m. to be -3 degrees Fahrenheit. The outside temperature increases by 2 degrees Fahrenheit every hour for the next 6 hours. If the temperature continues to increase at the same rate, what will the temperature be at 2 p.m.? So our first step, we're going to write a function that models the situation. So when we write a function, f of x equals, we're kind of modeling this mx plus b. So m is our slope, which would be the rate of change. So how much is the temperature changing? It's changing 2 degrees every hour. So we're going to let our m be 2. There's the 2 degrees times, we're going to let x be our number of hours. So maybe we should take note of that. X equals number of hours. And then when we took the temperature at 6 a.m., the temperature was -3, so we're going to say -3. If x is 0, if 0 hours have passed, 2 times 0 is 0, our temperature would be -3. -3 is the temperature at 6 a.m. So there's our function. Step 2, we're going to sketch a graph of the function. So this is slope-intercept form. Y-intercept is -3, so I'm going to go down 3 on the y-axis. Our slope is 2, so up 2 over 1. We can see we're going to end up with a line that's increasing. The temperature is increasing as time goes on. Now, when we draw in the line, we normally would draw arrows on both ends of the line. However, in this example, our time, if x is our time, when our time is 0, the temperature is -3. And our time is 0 at 6 a.m. when no time has passed. So we're not interested in -1, -2, -3. Any of these negative values for x don't make sense in the context of this problem because you can't have a negative number of hours. So what that means is instead of putting an arrow on the end, we're just going to have a closed circle on the end. So we're including that, and we're going to draw our line through here, and we're going to put an arrow because the line will continue in that direction. So there's the sketching a graph of our function. A reasonable domain for this would be when the time is 0, no time has passed at 6 a.m., and then all the way to however long we want to clock the temperature at different hours. And a range, because it's increasing by 2 degrees every hour, a reasonable range would be temperatures that are greater than -3, because that was our temperature when we clocked it, and then it increased 2 degrees every time. It's always good to make sure we understand what a reasonable domain and range would be for a situation. So step 3, find the y value at the specified time. So they're asking, what will the temperature be at 2 p.m.? Now our x is representing the number of hours, and we started this at 6 a.m. So how many hours have passed from 6 a.m. to 2 p.m.? And that is going to be a total of 8 hours. So we're going to let x equal 8. So we'll plug into our function. We want f of 8. So what's the temperature after 8 hours? We're going to do 2 times 8 minus 3. Again, no math over here. That's just our label. It's the same thing as y equals. 2 times 8 is 16 minus 3, and we get 13. So after 6 hours have passed and we're at 2 p.m., the temperature is 13 degrees. So just kind of a follow-up question and thought we should consider. In this situation we just talked about with this temperature increasing throughout the day, does a linear function realistically represent the temperature for the domain of 0 is less than x, which is less than 24? So if we think about the domain as hours pass, what we have from 6 a.m. to 2 p.m. is our temperatures increasing by 2 degrees each hour. So will that continue forever? Well, what's going to happen is the sun is going to set. And when the sun sets, we will no longer have that rise in temperature of 2 degrees every hour. We would say that the linear function is it's realistic, but only for a portion of the day, because we recognize that the temperature will not continue to rise 2 degrees every hour. So just to answer this, does it realistically represent? And we'll just say for only a portion of the day. Which means that this function that we came up with is a good representation of the situation, but only for a portion of the day.